Everybody. So just a little review on research before you take your test. And this will give you the answers for your independent and dependent variable review that you did. So let's take a look as we review valid research. So when you're doing valid research in psychology, you need to make sure that you pick a good research method that fits the question. Your sample can either be random or it can be stratified. Stratified meaning that it's not just random ages and genders, that you can actually select within a gender like females. You can randomly select in that, or by age or by social class. There's always a variety of ways that you can do that to make sure your sample represents maybe the whole population, but it's randomized. It's picking whatever people within that male, female, social class, or age that you want. You need to control for biases to help with valid data. We'll talk about that in a few minutes. And then you want to replicate your study and make sure that you report and replicate what you've done. So why is experiment used instead of descriptive study like a survey? Well, we can only use an experiment to find cause and effect relationships. That's the only way we can do that. We can find and use a correlational study for relationships, but not cause and effect. And that's because we're controlling the situation and decreasing the number of outside influences because we are using an experiment. Outside influences that could be other variables that would have caused that same result to happen. So what is the independent variable? An independent variable is what the experimenter changes or alters and then is going to observe its effects. And the effects that it has is actually the dependent variable. It's not controlled by the experimenter, but we're hoping that whatever we put into the experiment, whatever that item is or cause is, that's going to show the actual effect. So for independent variable in the experiment I did in class, it was the article that I gave you, either with a picture or no picture. And then I was looking to see if you agreed or disagreed with that question of whether or not it was more scientifically valid, because we were trying to look for if the picture actually affected the way that you viewed the article and its scientific validity. So for instance, an example of this would be an independent variable, the number of hours I study for a test. If I change the number of hours, then I see the effect on what the score of the test would be. So this would be positively correlated because as I study more for the test, my grade will also go up. So both of them are going in the same direction. It's correlated that way, but also we know that we can do an experiment with it because I can manipulate how many hours somebody studies for something, and then they take a test, the same test, and then we see what the difference in the result of that test would be. So that's the dependent variable. The experimental group, remember, is exposed to the independent variable. The control group is not exposed to it, and it ensures that the independent variable is valid. There's no other reason for that change. So if you have this placebo group or control group, somebody that's not getting the exposure to it, then you can see if that's actually the variable that's causing it. All right. Now, your whole population. So those are things that you have to be aware of when you're doing samples. That would be not generalized to the whole public. So a random sample, for instance, would be a psychologist choosing the 20th name on a school enrollment, when we talked about in class. So if you're drawing out any 20th name on a school enrollment, like in Carmel Clay, that would be a random sample. However, if I wanted to do it by age level and by grade level, I could do a stratified sample, and that would be for every age group or every grade level. Then I would randomly select every fifth person or whatever it might be. So that's the difference between just a random sample and a stratified sample. A random sample you just grab from anyone, and it could be something where they do the 20th name. That's still random. It doesn't, random being that it's not based on any kind of gender or grade level or whatever. So you could have more kindergartners than first graders depending on how many people are actually in that every 20th. And then for stratified, you're going to do a by age level. So within that, then you would do every fifth. And that's still random, but it has some more parameters on it. And what is the importance of randomization? Remember we talked about unless the participants are randomly assigned, the researcher cannot assume that the groups are truly equal. So we talked about this example in class, how because the evaluator was choosing or letting the kids choose which group they were going to go in, that was a problem because there are reasons why a student would choose the new math group versus the traditional one. Remember, we talked about how if you do well in math, you might choose the new instructional approach that she's trying to test if it works. And then if you're maybe not as good at math, maybe then you'd use the traditional approach. So then the results would be skewed because she's looking to see if she would recommend this new math approach to like Carmel Clay schools. And if there's good kids that do well in math, then they're going to do well in that, or have more of a chance of doing well in that new instructional approach. And then the kids that are doing traditional approach will still do poorly in that traditional approach. So you really need to have it where you're just choosing whoever's in what group, no matter what their skill level, and then really see who does well and who does not. Other ways of making sure that you don't have bias in your experiment is that you use single blind or double blind experiments, which I know you've talked about in science. With single blind, it's where the participant is not aware that they're getting the independent variable. So for instance, in something where they are using a placebo pill, if they're doing a study on whether or not in mental health or depression, antidepressant medication is working, they would give somebody the medication and somebody a placebo pill. And that in a single blind, that person does not know which one they're getting. In the double-blind experiment, the experimenter also does not know who's in what group, and then they just randomly will seek out and give that medication to the people, no matter what that pill is. And that helps to have them evaluate each person in a really unbiased manner and not look for things that would fill in. If they're really trying to prove that this antidepressant medication works and they know that somebody's taken the antidepressant medicine, then maybe they'd be looking for certain things that would prove that would. So if they don't know if that person has been given it, then they can look more objectively at the results. One way that this can be kind of faulty, though, is are they really double-blinded? In a study done with 73 cocaine users, the subjects were assigned to one of four groups. One that received a prevention psychotherapy, and they got the antidepressant medication. There was one that received the psychotherapy, which is like strategies and stuff like talk therapy kind of things, and they were given the placebo pill, so a sugar pill. Those who received a fake psychotherapy, one that wasn't really one that would work, and then also the antidepressant pill, and then those that received just bogus therapy and also the placebo pill. And what they found was that two clinical raters were able to guess correctly who was in what group 3/4 of the time of the cases. Now, why would that happen if it's double blind? So what they felt like is that because they are clinical raters and they know what it would look like if somebody was given an antidepressant or therapy, that they believe that they could kind of come up with those characteristics and kind of figure it out. But nevertheless, using single and double blind can really help in trying to reduce the amount of bias, although bias may still occur. All right, and then lastly, what are ethics and informed? Like, what do we do in studies to make sure that there's ethics being followed? These are all the APA, or the American Psychological Association guidelines, and they've had to develop those over time because people have done experiments in the past that have not been on the up and up. First of all, you need to give informed consent before engaging in an experiment. So somebody needs to volunteer to do it, and they also have, formally a legal consent. Is it ethical, though, for to use people who cannot give their informed consent? When would we be able to do that if we couldn't get that single person's consent? Those would be things like if we're trying to study Alzheimer's disease or schizophrenia or some kind of disability, or somebody under recreational drugs. We would then use a surrogate to try to get them to have a consent, at least somebody who is their guardian or power of attorney would sign that, because we still want to study people with those kinds of diseases, but they may not be able to do that, especially with schizophrenia, where you're trying to get somebody to sign their consent and they think they're signing away their bank account or signing their death certificate because they are paranoid that people are after them. That's part of the disease of schizophrenia. So we want to still be able to study those people, but we'd have to use somebody who is like their legal guardian or sick. Some ethics over time has really, developed these guidelines and so forth. Sometimes people in the past have volunteered to do things, and it's still been unethical. There was a study done with in Statiegee, Alabama, and it was done to try to help African American men who had syphilis. And it started in 1932, and they wanted to see if, the effects of syphilis on this 400 men that had it. Unfortunately, they were given a treatment, but it was a bogus treatment, and unfortunately, they were given a faulty promise of a free treatment and something that was going to do that. And so, even though they volunteered and they knew what was going on, you can see the men getting their injections there. They were denied effective treatment, so they really did not give their formal consent because they were lied to about what that medication actually was. And then as a result, 100 of the men died, and then women and children were also infected as well. And it wasn't until Bill Clinton in 1997 that he actually had an apology for what happened to these men. So in time, because of cultural, historical times, we've had to develop these guidelines to make sure that experiments are done. Okay, and then beyond that is what's the difference with correlational studies? Correlational studies, remember, just have a relationship. There's no causation. So a research study could talk about how morning people are more optimistic than evening people. And really, even though it's positively correlated, there are different ways that you can kind of look at this relationship. Being an optimist may cause someone to be a morning person. Being a morning person may cause you to be more optimistic. Optimism and being a morning person can influence somebody simultaneously, or it's some kind of third variable. That's why we can't say it's causation. Having a job makes people both optimistic and a morning person because they like where they're going. But we can use these if there's some kind of study that we can't do for experiments. We can use a correlation. So let's take this for instance. This was actually in an article in the news at one point. There's a new scientific evidence that ice cream consumption and homicide rates are strongly correlated and even explain mass shootings. Now, how would that actually be? Ice cream consumption and mass shootings or crime. That's actually something that is correlated. However, there could be some other variable, okay? So if we had that conclusion, then people start taking those correlations and really going with that evidence. People might go to state lobbyists and try to ban the sale of ice cream, and we wouldn't think that that's okay. There is a real conclusion on that. Homicide rates do rise in the summer when ice cream consumption also rises, okay? And so it's because really of the weather and the heat that gets people agitated, and more crime happens in the summer. More people are together as opposed to the winter when people are sort of separated in their homes more often. But because they're positively correlated, people could take information like that and run with it. So that's why it's important to realize that correlation is not causation. It just has a relationship. Okay, so you guys went and did your practice for independent and dependent variables. So let's see how you did. Number one, the first example, the independent variable is stress, job stress, and the dependent variable is they're measuring health, how job stress would affect health. For B, the history of abuse, and they're measuring depression, substance abuse, or addiction. Third one, education, and they're measuring dementia or cognitive disorders. And then the fourth one, special programs for teen parents and measuring their school performance and psychological health. And then E, religiosity, or how religious you are, and your marital satisfaction. All right, hopefully that helped and you guys are ready to take your test. Bye.